Welcome back to our deep dive. Today's gonna a little bit different. Usually we grab a stack of articles about, I don't know, clean energy or the history of coffee, and we sort of just wade in. But today we are opening a file that I have to be completely honest with you. When I first saw the title, I almost archived it immediately.
I can completely guess why. Did it have the word billing in the title?
It had billing, it had ledgers, it had invoicing, it even had the word taxonomy in there. It looked like the absolute driest, most bureaucratic piece of documentation I have ever seen in my life. I really thought, okay, this is for the accountants, this is for the CFOs, this is basically nap time.
Which is the trap. That is exactly the trap everybody falls into.
Right. Because then I actually started reading the source material, this autumn strategy guide, and specifically this one section titled The Token Ledger Inversion. And I'd say about 3 pages in, I actually sat up straight in my chair. I realized we aren't talking about accounting here. We aren't talking about sending PDFs to an accounts payable department. We are talking about a hidden crisis that is effectively strangling the artificial intelligence industry right now.
It is the invisible bottleneck. It really, truly is.
Exactly. So we're calling this the practical jobs to be done deep dive. And the claim here is massive. The authors are arguing that there is a paradigm shift happening, like right now, right under our feet, that is just as big, just as physical and structural as the move from on-premise servers to the cloud back in the mid-2000s. But instead of servers, it's about the fundamental atomic unit of how we monetize value in software.
And look, I know paradigm shift is a phrase that gets thrown around in tech marketing every single day. Someone invents a toaster that connects to Wi-Fi, and suddenly they call it a paradigm shift. It's usually just fluff.
Yeah, totally.
But in this specific case, I actually think the comparison holds up. I think it's a necessary term. But we do need to ground this immediately, because this isn't about philosophy or high-level economics. It's about raw engineering pain.
Right. Let's get to the actual reality of it.
The entire premise of this deep dive is that AI companies, and I'm talking about the hot startups, the scale-ups, even the internal experimental divisions at big tech companies, they are all bleeding out. And they are bleeding because their models are bad. The models are absolute miracles right now.
Incredible stuff.
And they aren't bleeding because they lack customers. Everyone on the planet wants AI. They are bleeding engineering hours, precious, incredibly expensive hours, trying to force usage-based AI models into legacy billing systems like Stripe that were fundamentally designed for selling T-shirts or standard monthly software subscriptions.
Okay, let's unpack this, because the character at the center of the story isn't the visionary CEO giving the big TED Talk. It isn't the venture capitalist writing the giant check. It's a very specific, very tired person, the L3 backend engineer.
Exhausted L3, yes.
The exhausted L3. Let's paint a portrait of this person for you for a second. This is someone earning, fully loaded with equity, benefits, insurance, all that overhead, probably around $300 an hour.
Easily, if not more in today's market.
And they are brilliant. They know Python, they write in Rust, they understand complex distributed systems, they understand vector embeddings and neural network architecture. They should be building RAG pipelines, retrieval augmented generation. They should be optimizing inference speeds to make the AI smarter and faster for the user.
They should be inventing the future. That is literally what they were hired to do.
Exactly. But instead, according to our sources, they are wasting weeks, literally weeks of their lives, building brittle Postgres database tables. They are writing webhook listeners. They are spending their Friday nights debugging why a credit card transaction failed in a way that randomly locked a user out of a chat interface.
And that is the true tragedy of the current moment in tech. You have these incredible minds, people entirely capable of building the next AGI, and they are stuck writing basic glue code for a credit card processor. It's a misallocation of talent on a global scale.
So let's dive into the history here. How did we get into this mess? Because the default assumption in the industry, the Stripe is enough trap, as the guide calls it, is that, well, Stripe is enough, and for the last 10 years, Stripe was enough. It works for Netflix, it works for Salesforce, it works for the local coffee shop down the street. Why doesn't it work for an AI agent?
It's a classic case of what the source calls solution bias. We see billing strictly as a financial problem. We think, okay, I need to move money from customer A to my startup's bank account. And Stripe is the gold standard for moving fiat money. No one disputes that at all. If you need to charge a credit card, you use Stripe.
Right. If I'm selling a monthly subscription to a project management tool, I charge you $20 on the first of the month. Stripe takes the money. Done.
Exactly. In a traditional SaaS software as a service world, monetization is a state. It's a binary condition. Is the user paid up? Yes or no? The system checks once a month. It's incredibly low frequency. It's predictable. It's basically just a database row that says status active.
It's a simple toggle switch.
But AI is not a toggle switch. AI is a high-pressure fire hose. AI is purely usage-based. It's wildly volatile. A user might spend 10 cents on Monday asking a few questions. Then on Tuesday, they hook up an autonomous research agent to your API, and they might burn through $500 of compute in 45 minutes.
So you're dealing with high-frequency, totally variable consumption, kind of like a utility bill.
It's actually even faster than a utility bill. A utility bill aggregates your power usage once a month. This is more like high-frequency stock trading. You are consuming massive computational resources in real time, often in sudden bursts, often running in parallel. And that's where the stripe is out. Enough trap violently snaps shut. When a startup tries to use a standard subscription tool for this, they enter what the guide dramatically, but I think very accurately, calls the 3-week Postgres purgatory.
Oh, I love that term. Purgatory. It sounds just awful. It implies this endless suffering with absolutely no guarantee of salvation. Walk us through the mechanical reality of this purgatory. What is physically happening to that poor L3 engineer sitting at their desk?
So imagine you're that engineer. You're building, let's say, chatbot X. You need to charge your users for tokens because every single time someone talks to your bot, you have to turn around and pay OpenAI or Anthropic for that compute. But Stripe doesn't natively understand tokens in real time the way your local application does. Stripe understands invoices and monthly subscriptions. So you have to build a bridge.
You have to translate those tokens into dollars and tell Stripe about it.
Right. But it's not just casually telling them. You have to manually manage Stripe's 5 distinct subscription functions. You have to create products, set prices, manage customers, map subscriptions, and log usage records. And to keep your app in sync with Stripe's servers, you have to build listeners for webhooks.
Okay, let's pause on webhooks for a second. For any non-technical listeners out there, how would you define that?
A webhook is basically an automated digital message that Stripe sends over the internet to your server saying, hey, something just happened, like payment succeeded or payment failed or subscription created.
Okay, that sounds pretty useful. Just a notification. Hey, Dave paid his bill.
It is extremely useful. But here's the massive kicker. Webhooks are asynchronous.
Meaning they don't happen instantly?
They happen mostly instantly. But sometimes they arrive 2 seconds late due to network traffic. Sometimes they arrive entirely out of order. Sometimes, rarely, but it definitely happens, they fail entirely. Maybe your server blips for a microsecond and completely misses the message. So now, you, the engineer, are writing thousands of lines of code just to handle the edge cases. What if the message doesn't come? What if the message says paid, but my database says unpaid? What if I get the exact same message twice?
You're basically having to build a reconciliation engine.
You are building a bank. Right. You are effectively trying to keep 2 complex ledgers, Stripe's ledger floating in the cloud, and your local Postgres database on your servers in perfect synchronization in real time. And you are trying to do this while your user is blasting thousands of API calls a minute at your system.
And if they get out of sync?
Catastrophe. Absolute catastrophe. There are 2 main scenarios. One, the user pays, Stripe knows they paid, but your database missed the webhook because of a network timeout. You end up locking the user out. They have physically paid you money, but they can't use the tool. So they churn. They cancel. They go to Twitter and loudly complain that your app is broken.
Which is obviously terrible for business.
But scenario 2 is actually worse for your bank account. The user runs out of money. Stripe knows who failed the payment. But your local database hasn't gotten the memo yet because a webhook is delayed by 30 seconds. So you just keep letting them generate high-res images. You're aggressively burning your GPU cycles, which you were paying NVIDIA or AWS for, completely for free.
Ah, and that's what the guide calls the brittle webhook penalty.
Precisely. It creates a system that is so utterly fragile that startups become terrified to even touch it. I have personally seen this happen in real boardrooms. A CEO walks in and wants to change pricing. Maybe they want to introduce a new pro tier or lower the cost per token because OpenAI just dropped their underlying prices.
Which seems like a totally normal, healthy business move. Hey, our costs went down, let's lower prices to get more users.
It should be the easiest decision ever. But the engineering lead goes pale. They look at the CEO and say, we can't. If we touch the custom billing code, we might break the sync logic. We might accidentally take down the whole app for 3 days.
So business innovation is completely paralyzed because the underlying billing infrastructure is made of glass.
Correct. And that brings us to what I think is the most savage metric in this entire document, the ID10T index.
The ID10T index. I saw that and I actually had to laugh out loud. For anyone listening who hasn't worked in IT, an ID10T error is an old help desk joke. If you write it out, it spells EDIOT. It usually means the problem is the human sitting at the keyboard. But here, they are using it as a highly serious economic metric.
It's a brilliant framing, though. The ID10T index compares what companies are paying for their billing infrastructure, specifically the human capital cost,
Yeah.
against the absolute laws of physics.
Okay, let's break down the math on this because it's fascinating. Let's look at the numerator first, the waste.
The numerator is that L3 backend engineer we talked about. We established they cost about $300 an hour fully loaded. Now, the source says there is an initialization tax. Just to get the first webhook functional, to build that first brittle bridge to Stripe, takes about 120 hours of focused engineering time.
Which is 3 solid weeks of work.
That's $36,000 just to turn the lights on.
Yeah.
Just to be able to accept a single solitary dollar from a customer without the app crashing.
Ouch. That is a steep tax.
But it gets worse. There's also the maintenance drag. You're probably spending about $1,500 a week, maybe 5 hours of engineering time, just debugging dropped webhooks, fixing sync errors, updating API versions because Stripe rolled out an update. That's another $78,000 a year.
So we are talking well over $100,000 a year in purely engineering time, not cloud server costs, it's human time, just to keep the billing system from exploding.
Right. That is your numerator. Over $100,000. Now look at the denominator. This is what the guide calls the physics floor. What does it actually cost in terms of raw computing power to log a transaction, to flip a Boolean value in a database that says user has credit?
I'm guessing it's significantly less than $100,000.
It is so much less. AWS API Gateway processes web traffic at about 90 cents to $3.50 per million requests. An actual database Boolean flip costs microscopic fractions of a cent.
So wait, let me get this straight. We are paying hundreds of thousands of dollars in premium human capital to build and maintain a system that executes a task literally worth $1.10 per million actions.
That is the efficiency delta.
Yeah.
And that is exactly why the ID10T index is so incredibly high. It highlights the absolute absurdity of the current approach. We're basically using a sledgehammer made of solid diamond to crack a tiny walnut.
And it's not just the pure cash, is it? It's the opportunity cost. I mean, if I'm a startup founder, that $36,000 in time represents a month of runway. Or it represents a massive new feature. That is money that is fundamentally not being spent on making the actual AI better.
Exactly. That 36 grand is money not spent optimizing your RX pipeline. It's not spent training your proprietary model. You are actively burning your most valuable resource engineering focus on administrative plumbing. It's exactly what Google famously calls toil.
Toil. I really like that word for this.
Google defines toil as work that is manual, repetitive, tactical, devoid of enduring value, and scales linearly as the service grows. Building custom billing synchronization logic is the absolute textbook definition of toil.
So we have established the problem pretty clearly. The current system is a trap. It's wildly expensive, it's completely brittle, and economically, it's mathematically absurd. This leads us directly to the core insight of the Autumn Strategy Guide, the actual solution, what they call the token ledger inversion.
This is the big aha moment of the paper. This is where we stop just complaining about how bad the problem is and look at the structural architectural fix.
So what exactly is this inversion? Is it just, slightly better software?
It starts with fundamentally admitting that a fiat-movement engine, which is exactly what Stripe is, cannot serve as your dynamic infrastructure layer. You have to completely separate the two concepts. You need a financial ledger, which handles the slow, highly regulated, compliance-heavy banking stuff. And you need a separate access control ledger, which handles the incredibly fast, compute-heavy token tracking.
Okay, so instead of trying to somehow make Stripe fast, which it fundamentally isn't designed to be, you build a totally separate layer that is natively designed for millisecond speed.
Correct. And the structural shift here for the engineering team is moving from build to query.
Build to query. Explain how that works in practice.
In the old model, the Postgres purgatory model, the engineer has to physically build the logic. They write the custom code that checks the user balance, updates the database, syncs with Stripe. They have to write the if statements like, if user balance is greater than 0, then deduct cost. They own all that logic, and they own all the inevitable bugs in that logic. But in the inversion model, the engineer simply queries a centralized, purpose-built ledger.
So they just ask a question.
They just ask, can this user do this thing? And the high-speed ledger replies, yes or no.
That sounds infinitely simpler.
It is technically vastly superior because it treats billing as an ultra-fast, low-latency data store sitting right next to your core application logic. It stops being a remote banking process that you have to nervously wait for over the internet. It becomes a simple, fast variable in your code.
You know, this really reminds me of how we treat authentication now. Think back 10 years ago. Every single developer built their own custom login systems. You'd write the code to hash your own passwords, you'd store them in your own database, and you'd just cross your fingers and hope you didn't get hacked.
And practically everyone got hacked eventually.
Right, it was a mess. But now, you just use Asu or Clerk or Okta. You just ping an API and ask, is this user logged in? You completely offload the complexity to a specialist.
Exactly. You offload the complexity, and in this specific case, the source material breaks this new architecture down into what they call the three-function paradigm. They claim the entire 3-week sprint, that whole $36,000 nightmare, can literally be reduced to just 3 API calls.
Just 3 calls? Come on, that sounds a little too good to be true.
They call it the zero-waste target. Let's actually walk through them.
Okay, hit me. Function number 1.
The first function is autumn.checkout. This handles the fiat on-ramp. This is the UI window where the human user puts in their actual credit card. It deals with the legacy banks. It offloads all the regulatory and compliance burden. That's the slow part, but it happens very infrequently. Maybe once a month when they refill their account.
Right. That's just the filling the wallet part.
Exactly. Then the second function is autumn.track. This is what they call the burn down. This is asynchronous fire and forget. Your AI agent generates an image, and your app just sends a quick ping to the ledger. User consumed 5 tokens.
And you don't even wait around for a response.
No, absolutely not.
Yeah.
You don't want to slow down the user experience waiting for a receipt. You just log the cost in the background. It's exactly like a passive meter reader on your house.
And the third function?
A third is autumn.check. This is the gate. This is the absolute most critical one. It's a sub-10 millisecond Boolean query. Right before your AI runs an expensive prompt, it asks the ledger, does this user have enough balance? And it returns a simple true or false instantly.
Checkout, track, check. I mean, it sounds deceptively simple.
That's the entire point. It applies what the source refers to as the Musk loop. You know, Elon Musk's core engineering philosophy.
The best part is no part.
It's exactly. Step 1 of the Musk loop is to delete the unnecessary part. This specific architecture completely deletes polling. You aren't constantly asking your database, are there tokens left? Are there tokens left every single second? You just dynamically check at the gate. And even more importantly, it deletes complex math. You aren't desperately trying to track fractions of a cent in real time. You're tracking whole integer compute units.
Wait, I really want to dig into that complex math bit for a second. The source mentions tracking compute units or CUs instead of tracking fractions of cents. Why is that such a massive deal? Why wouldn't you just track the dollars?
Because floating point math, which is decimal math, is actually incredibly dangerous in computer science.
Dangerous how? Like, the computer's going to explode.
No, but your company's balance sheet might explode. Computers are actually notoriously terrible at decimal math at scale. If you try to subtract 0.1 from 1.0 10 times in JavaScript or Python, sometimes you don't end up with 0. Sometimes you end up with 0.000000001.
Rounding errors.
Exactly. Microscopic rounding errors. And in finance, rounding errors are strictly illegal. You literally cannot lose a single penny. So if you try to track everything in dollars and cents, specifically trying to track tiny fractions of cents for individual AI tokens, you have to use very heavy, highly complex data types in your database to ensure absolute precision.
Which fundamentally slows the whole system down.
It drastically slows things down and adds massive overhead. By abstracting it away to compute units, just saying, hey, this specific action costs exactly 5 integers, you make the math incredibly fast and perfectly precise. 10 minus 5 is always exactly 5.
And then you just convert those whole units back to actual money at the end of the month.
Exactly. You decouple the physical resource tracking from the financial value tracking. The resource tracking happens at the speed of light using simple integers. The value tracking happens at the speed of banking using complex dollars.
That is a very subtle but incredibly profound architectural decision. It's really decoupling the physics of the compute from the finance of the business.
Which is really the overarching theme of this entire deep dive, isn't it? The token ledger inversion is fundamentally about realizing that physics and finance simply have to operate on completely different timelines.
I really love that phrasing. Physics and finance operate on different timelines. Somebody should print that on a tech conference t-shirt.
I would absolutely wear it.
I want to circle back to something you mentioned earlier, That paralyzed CEO who wants to change pricing but can't. How exactly does this new architecture fix that specific problem?
Ah, this is what the paper calls the migrate price IDs failure node.
Uh-huh.
In the old brittle way, if a CEO says, hey team, I want to change the price of generating an image from 1 token to 5 tokens, that is a massive code change. The backend engineer has to physically go into the database schema, write a complex migration script, update the core logic, test it, deploy it, and just pray nothing breaks in production. It's easily 40 to 80 hours of high-stress work.
All of that just for a simple price change?
Yes. But in the new way, the inverted autumn way, that pricing logic is totally decoupled from the code base. The CEO or the product manager just logs into the autumn UI, finds the setting, and changes image generation equals 5 tokens. That's it. The actual application code doesn't change one bit. The app is still just asking autumn.check. The mathematical answer to the question changes, but the code asking the question stays exactly the same.
Wow, that's liberating. It sounds like it effectively turns pricing into a dynamic product feature rather than a terrifying infrastructure project.
It turns pricing into a lever you can actually pull and play with. You can iterate, you can run A/B tests, which in a market as wildly volatile as AI is right now is basically survival.
So we've got the theory down, we've got the architecture, but does it actually work in the wild? I mean, developers are a notoriously skeptical bunch. You can't just sell them a fancy theoretical idea. What does the hard data say about actual adoption?
This is where the paper gets really interesting. The authors looked at what actually drives developer adoption for these tools. They ran a full Pearson correlation analysis.
Getting highly statistical on us, I see.
Always. They found that enterprise UI aesthetics, meaning how pretty the analytics dashboard looks to a manager, scored an absolute zero correlation with developer adoption. Developers literally do not care if the dashboard looks nice.
So what do they care about?
Time to first successful API call. That single metric drives 90% of the adoption.
Deed to value.
Speed to proving it works. The authors call it the 5-minute win. A developer must be able to sign up, install the SDK, and physically see a token logged in their terminal within 5 minutes flat. If it takes 6 minutes, they get bored or frustrated and you lose them entirely.
That is a brutally tight window.
It is. But it deeply speaks to the urgency of the problem. The source talks about the top box gap, urgency. Developers are not staying up at night worrying about accepting credit cards. That is a comprehensively solved problem. Stripe solved it a decade ago. What they care about, what gives them actual stress streams, is preventing negative token balances without introducing latency into their app.
Because latency completely kills the AI illusion. If I'm chatting with a smart bot, and it has to pause for a full second to think about my billing status before it answers me, that feels broken.
Exactly. And that's exactly where the sustaining innovation strategy comes into play in the paper. The document argues that Autumn isn't even trying to compete with Stripe on moving finance. They are defending against Stripe's internal Metronome product. Metronome is a billing tool Stripe acquired a while back. But Metronome is fundamentally designed for CFOs. It's big, it's highly complex, it has gorgeous financial reporting. Autumn is laser-focused on the L3 engineer.
It's a specialized tool for the builder in the trenches, not the accountant in the boardroom.
And that is a massive strategic wedge.
Now, I want to dramatically zoom out for a second. We spent a lot of time talking about AI startups today, but this Autumn strategy guide heavily hints at something much bigger toward the end, a legacy. It mentions Pathway C and the future of compute itself.
This is definitely the visionary part of the text. This is where we leave the practical, how do I bill for my chatbot conversation, and officially enter the what does the future global economy look like conversation.
Let's start with lateral expansion, because this inversion concept isn't strictly just for AI, is it?
No, not at all. The guide points out that this architecture is actually a universal usage ledger. Think about massive video rendering farms. Think about transactional email APIs. Think about literally any digital service that consumes computational resources variably.
Right. If I'm sending a massive newsletter, I'm not paying a flat $20. I'm paying per 1,000 emails sent.
Exactly. And the exact same Postgres purgatory exists for those legacy infrastructure companies too. So the argument is that Autumn can apply this high-speed token logic to non-AI firms just as easily. But, and this is the big but, that's just the appetizer. The main course of this paper is Pathway C.
The agent economy.
Yes, the disruptive vision.
Okay, set the scene for us here. What happens when we fully shift from traditional SaaS to a true pay-for-compute model?
The guide argues, quite aggressively, that the monthly subscription, the standard $20 a seat model we all know, is completely dead.
That is a remarkably bold claim.
It is, but the underlying economic logic is really sound. Flat subscriptions inevitably fail for light users because they eventually realize they are overpaying and they churn. They just don't use it enough to justify $20 a month. And at the same time, subscriptions fail for heavy users because those power users absolutely obliterate your profit margins by consuming too much expensive compute.
So it's a lose-lose structure in a high compute environment.
Exactly. So the inevitable replacement is the auto-burn wallet. I want you to think of it exactly like an automatic toll tag on your car's windshield. You load $50 into the account, and as you drive around or as you use the AI, it silently deducts fractions of pennies in the background. When your balance gets critically low, it just automatically tops up another $50 from your credit card.
Simple, completely frictionless for the user.
But here's where the concept gets genuinely wild. Agent-to-agent commerce.
Oh man, this is the real sci-fi stuff.
But it's becoming reality incredibly fast. In the very near future, you as a human won't just be sitting there typing prompts into an AI agent. Your AI agent will be autonomously hiring other specialized AI agents to complete subtasks for you.
So my general scheduling agent might go out and temporarily hire a specialized local research agent to look up a restaurant's availability.
Exactly. But here's the massive fundamental problem with our current financial system. Imagine your scheduling agent needs to pay that specialized research agent exactly $0.001 for that microtask.
What tenth of a single penny?
If you try to run that specific transaction through the traditional Visa or Stripe rails, the minimum network fee is often 30 cents plus 2.9%.
So the transaction fee is literally 300 times the actual cost of the service.
Which is completely insane. The math completely breaks down.
Yeah.
You simply cannot build an autonomous agent economy on top of legacy credit card rails.
So what is the actual solution proposed here?
A completely closed-loop, high-speed ledger. The token ledger inversion creates a parallel system where these autonomous agents can trade compute units, let's keep calling them CUs, instantly with absolutely zero transaction fees.
Like using internal plastic chips inside a casino.
Yes, perfect analogy.
Okay.
Agent A pays Agent B 5 CUs for a task. The Autumn ledger simply updates the database instantly. No traditional bank is involved in that moment. No legacy credit card network fee is triggered. The system only settles up via fiat money once a month, or whenever the digital wallet needs a major refill.
So it aggregates millions of tiny, rapid microtransactions into one single, efficient macro transaction.
Precisely. And this structurally positions the ledger as the equivalent of a Swiss bank account for the emerging machine economy. It's highly neutral, it's open source, and crucially, it is completely independent of the emerging Stripe and OpenAI walled garden.
That is just a massive, sweeping vision. It's not just about selling a better billing software library anymore. It's about building the core protocol for value exchange between machines.
It is the financial nervous system for global AI traffic.
Wow. Okay, that is a whole lot to digest. We have gone all the way from the intense frustration of a local database error to the macroeconomic future of the autonomous economy.
It's a very steep curve, I know.
Let's try to bring it back down to earth for a final thought. If I'm listening to this right now, and I'm that L3 engineer, or maybe I'm a startup founder managing a team of them, what is the single most pragmatic takeaway from this entire guide?
The takeaway is incredibly blunt. Stop building billing systems. If you are sitting there right now coding a custom webhook listener for Stripe, stop typing. It is an ID 10T error. Audit your specific numerator and denominator. You are actively paying a massive premium to build technical debt that will eventually break your company.
And looking at the much bigger picture.
We are witnessing the literal birth of a brand new layer of the internet. The how we pay layer is fundamentally changing to match the incredible speed of the how we compute layer.
It really is a absolutely fascinating shift to watch happen in real time. And I want to leave our listeners with a provocation, just something to chew on as they go back to their day jobs and their code base.
Go for it.
Ask yourself this. Are you currently building infrastructure for the human users of 2020 who sit patiently at a desk and manually type in a 16-digit credit card number?
Mm-hmm.
Or are you building for the autonomous AI agents of 2026 who need to transact at the literal speed of light? Because if you're still building for the humans, you might already be economically obsolete.
That is both a terrifying and deeply exciting thought to end on.
It really is. Thank you so much for walking us through this deep dive today.
It was my absolute pleasure.
And thank you all for listening. Keep analyzing, keep optimizing, and seriously, for the love of clean code, stop building your own billing systems from scratch. We'll see you in the next deep dive.